Welcome to our discussion on visualizing data, and specifically we're going to be talking about data presentation. And so what this involves is knowing what kind of graph you would make for each kind of variable. So quickly let's review the different levels of measurement. We have nominal, and that is our unordered categories or groups. We then have ordinal, ord for order, and so those are ordered categories or groups. And then we have scale, and that is equally spaced intervals. So if we have a variable and it has at least two categories, we can say it's nominal. If those categories are in a specific order, then we would call it ordinal. And if those ordered categories are equally spaced, then we call it scale. And so it just becomes more and more and more specific as we go up. These bottom two, if you remember, are known as categorical because we have categories for both of them. And then this top one is known as continuous. And those words will actually come in handy when we're thinking about the different kinds of graphs. So let's name the different graphs that we would use for each of these. And the categorical variables actually use the same kind of graph, so we'll just put them all together. But let's start with our scale variables. You may have learned that the stem and leaf plot is a good way of visualizing or presenting our data on scale variables. And scale variables are things like age in years, height in inches, blood pressure in millimeters of mercury. And so we have this little ruler that we're kind of imagining that shows those, which they don't look very equal on my ruler, but that shows those equally spaced intervals. The other graph that is more common for a scale variable is called a histogram. And what we'll see, oops, let's undo that. What we'll see is that a histogram basically is these categories that are equally spaced, and then we just show how many people are in each of those adjacent categories. So that's what a histogram looks like. And they don't have to necessarily be a certain shape. A lot of times you'll see a histogram, and let me put a different color on here just so you can see it. A lot of times you'll see a histogram with a normal curve superimposed on it, and then you can see if those bars are in fact normally distributed. If you see a graph with vertical bars and you have that shape kind of superimposed on it, then you know that it's a histogram. If we move on then to the categorical variables, there are two types of graphs that are common for this level of measurement, and that is the bar graph and a pie graph. And a bar graph looks a lot like a histogram. In fact, a histogram is a special kind of a bar graph, but a regular bar graph has bars, only there are spaces in between the bars. And so you'll notice that there's this distance that's between them. They are not adjacent to each other. It's not contiguous. In other words, it's not continuous from one to the next. And so let's get rid of some of those little funny dashes. I'll put these back. So that's what a bar graph looks like. It has these bars, but they are not touching each other, in other words. And so then each of these categories might represent the unordered categories or groups of the nominal variables, categories A, B, C, and D, and so on. Or it might represent the ordered categories of 1, 2, 3, and 4 of an ordinal variable. In the case of the unordered, we could put those in any order that we want to. In fact, sometimes we go from the highest bar to the lowest. We switch up the order just so that it's easier to look at. In an ordinal variable, these ordered categories, we would not change the order typically when we're creating a bar graph. Now in a pie graph, we basically start out with a circle, and then the sections of the pie represent how those different categories are distributed. And so we might have category A, B, C, D, E, F, and so on. Or these would represent categories 1, 2, 3, 4, 5, and 6. And a lot of times the question comes up, how would I decide if I'm going to use a bar graph or a pie graph? And here's the difference. It depends on what you want to show. A bar graph will show the relative frequency, so I'll put relative freq, of each of those categories. So it shows that one is taller than the other, whereas in a pie graph, sometimes it's a little hard to tell which one is the biggest piece of pie, especially since they're sort of scattered around a radius. Whereas the pie graph shows a proportion of the whole. And so if you want to show that it's a big part of the whole, what part of the whole is that particular category, then you would use a pie graph. Now, using one or the other often isn't wrong. It's just that you want to show a certain thing. And so typically, most of the time in statistics, you'll see bar graphs, but pie graphs are really popular, and you're able to visualize things really well. And so that can also be a really good way of showing certain things. So that's kind of a summary of the kinds of graphs that we use for, and this is specifically for descriptive statistics. And one of the things that I like to think about in terms of descriptive statistics is we are showing pictures and numbers and words. So the graphs is the picture part. And who likes to look at a picture? Everybody. A picture paints 1,000 words, right? And so it's easy to look at a picture. Whereas if you're looking at a table and there's just like lots of numbers in there, it sometimes is hard to sort through and figure out which one is the larger one. A picture really helps engage people. And so the numbers really are reserved for the people who are really into looking at the specific numbers that go along with the picture. But the picture and the numbers really represent the same things. And so descriptive statistics is those pictures and numbers, and a lot of times we write then an interpretation about the pictures and numbers. So we have pictures and numbers and words, pictures and numbers and words. So as we're going through these descriptive statistics, we're creating pictures and numbers and words. So there are a few other things that I want to share with you about these pictures. And so we're really talking about the stem and leaf, the histogram, the bar graph, and the pie graph. And so whenever we have any kind of a distribution, we have these three defining aspects of a distribution. So let me write that up here, 3 defining aspects of a distribution. Okay, so here are the three. They are shape, location, and spread. And so for our three defining aspects of a distribution, if we're looking at these scale variables, the shape is important. And so I'm going to put a yes here under shape. And shape specifically, remember, is looking at modality. It's looking at kurtosis. And don't worry if these words aren't familiar, and skew. We will learn more about these in the next statistics topic. So the main thing here is that with scale variables, we are interested in shape. And the reason is because they're contiguous, because they're touching here along this continuum, the shape really matters. Modality, does it have one or two or several peaks? Unimodal, bimodal, multimodal. Kurtosis, is it Is it pointy or flat, or is it sort of like the normal curve? Skew, is it to the left or to the right? And so we really care about the shape because the data, it's important for scale variables that we know what kind of shape it is. In terms of location, there are three ways of really looking at location. We can look at the mean, and I'm going to just use a Greek mu for that, mean. We could look at median, or we could look at mode. Now, mean and median are very important for scale variables. Mode, sometimes we might look at the most common, but if we're measuring to a certain level of a level of specificity, then mode, every single person in our data set may have a different measurement if we're being super accurate. And so mode is less important probably for scale variables than mean and median. And mean we use more often when we have this normal shape, this curve that looks like a bell shape. And median we use more when we don't have that bell shape, if we have multimodality or we have kurtosis or skew. So those are some kind of things that we like to think about. In terms of spread, the types of things we measure that go with mean are standard deviation and variance. And so you're going to be hearing a lot about these. So if we care about mean, then we also care about standard deviation and variance. The kinds of things we measure for spread that are related to median are the range or interquartile range. And then we don't really have a measure of spread that goes with mode. So for scale variables, we're interested in all of these. We're interested in shape, we're interested in location, we're interested in spread. Now when we drop down to the ordinal variables, we maybe would be interested in shape. And because these are ordered categories, but they are not contiguous, in other words, along this line, there are gaps. Some of them may be spread farther apart than others, in other words. The primary thing that we're really interested in for ordinal variables would be that modality. Do we have kind of like this funny shape where we have a peak on the left and on the right-hand side, like on the high and the low? Do we have a peak in the middle, say on a Likert scale from low to high? Are they sort of uncommitted to either end of the spectrum? So we're interested in that, but we really can't get at kurtosis or skew because we don't have anything that's touching. Kurtosis and skew can only be measured when we have a continuous or a scale variable. So that's why I put the maybe in here, right here. For location, if we think about mean, median, and mode, we actually cannot measure mean. It's not allowed. Mean is an arithmetic average, and if we don't have the bars touching, if it's not on a continuum, then we can't calculate a mean. So therefore, if we think about standard deviation and variance, we also cannot measure that for an ordinal variable. However, we can measure interquartile range and range overall for a ordinal variable, and mode suddenly starts to make a lot more sense. Which is the group that has the most in it? In this case, it's B. B is the highest bar, and so we do care about mode when we're looking at ordinal variables. Finally, in terms of this shape, location, and spread for nominal variables, for shape and nominal variables, it would be absolutely no. There's not any situation I can think of where we would care about the shape of that distribution because it's not really a distribution. If those categories are not in a particular order, then the shape would change if we put the groups in a different order. So we do not care about the shape. For location, if we think about mean, median, and mode, we also here similarly cannot calculate the mean. We also cannot calculate the median because median is the middle value. And if we put the groups in a different order, if they aren't locked into a specific order, then the middle value would change. And so mean and median make no sense at all for nominal variables. Similarly, if we look at standard deviation and variance, because we are not on a continuous scale, those make no sense to calculate for a nominal variable. Interquartile range or range are, you could technically have the computer calculate them for you, but they don't mean anything. And so really for nominal variables, the only thing we're left with is mode. In other words, what is the largest group? And if you just look at this pie graph, I'm guessing that A is the largest group. A lot of times we will put that at the beginning, or we'll change the order of those unordered groups if we need to, so that one will be at the beginning of the pie, starting at kind of the 12 o'clock position. But mode, whereas mode doesn't really make sense at all for scale variables, it does. In fact, it's the only way of measuring sort of this measure of location for a nominal variable. So that concludes our discussion on visualizing data. In summary, for a scale variable or continuous, we create stem and leaf plots and histograms. For nominal and ordinal variables, which are categorical, we create bar graphs and pie graphs. So I hope this has been helpful to you as you are learning about data presentation.